Hi friends, today we are going to take some glimpse on Dijikstra's algorithm. This will be useful for us to get the shortest path from one particular vertex to all other vertices. First, we'll go to the procedure, step 1, step 2, step 3, step 4. Now step 1, it says that consider a vertex A, and we are going to consider that as P is equal to A, and we are going to remove that A which we have chosen from the vertex at V. Okay, V minus A, that will be my T. Now T, that is T contains now the remaining vertices. Now for those vertices which belongs to capital T, we have to calculate the index. L of T is nothing but index of small t. So that first stage index we can calculate W of A comma T. W of A comma T means weight of an edge A comma T. Correct? Now the second step, select the vertex in T, capital T. Whatever the element it will be there in T, we have to collect that. In that one, we have to identify the one with smallest index. Okay, smallest index with respect to P. Let X denote that vertex. Now step 3, if this vertex index of this vertex of Z is known, means if they ask the last vertex, then if the index of that is known, then we can stop. If not, we are going to include that in my P, and we are going to exclude that from T. See, we have taken here P dash is equal to P union X, and we are going to remove that X from T. So we are going to keep on repeating this process until we won't have any vertex to find the index. Correct? See, that's what we have taken step 4. Return to step 2 and step 3 with P dash instead of P and T dash instead of T. So we'll take one example, then it will be clear for us. Here they are asking us, using Dijikstra's algorithm, okay, obtain the shortest path from vertex A to each of other vertices of the weighted directed graph. See, you may observe this is the graph that they had given. It is weighted and it is directed because direction also has been given. Now we have taken the vertex set of graph. So it contains a total 7 vertices A, B, C, D, E, F, G. We have taken that. See, A, B, C, D, E, F, G. Okay. Now as in the first stage, we are going to consider A, because from vertex A we have to calculate the shortest path to all other vertices. We are going to choose my P as A. Okay. Once we choose P as A, remove that A. Okay. Remove that A from vertex set. So once you remove this A from the vertex set, you are going to get the remaining vertices B, C, D, E, F, G. Total vertex set is A, B, C, D, E, F, G. Since we have removed A, we are going to get B, C, D, E, F, G. Now we have to calculate the index of each vertices which are present in T. That is, we have to calculate index of B, C, D, E, F, G. Now index of B means what? It is the weight of the edge AB. Now concentrate this graph. So there is an edge from A to B. The weight of that is 4. So therefore index of this vertex B is 4. So that's what here we have taken 4. Correct? Now index of C is weight of the edge AC. So carefully concentrate the graph. What is the weight of the edge AC? It is 6. So therefore index of this vertex C is 6. That's what we have taken here. Okay. Next, index of D means what? Weight of an edge AD. Okay. A means already chosen vertex. So from that vertex to the current vertex, weight is 8. From the figure you can make out that. Okay. Now see here, A to D. Okay. Now index of E is infinity because there is no edge from A to E. Correct? There is no edge from A to E. So therefore index of E will be infinity. Correct? So same thing, index of F is also infinity and index of G is also infinity. See, that's what we have taken. No edges there between A and E. Similarly, no edges there between A and F. Similarly, no edges there between A and G. So therefore it was infinity. Next onwards, whenever we want to calculate the index, we have to use the formula L dash of T is equal to, means new index of the t in capital T is equal to minimum of L of t comma L of x plus omega of or W of x comma t. So L of t means what? Index of the previous. The L dash of t means index of t. New index of t is equal to minimum of previous index of t comma the index of the chosen vertex plus weight of the edge of the chosen vertex and the current vertex. See, that's what I've written. Current vertex index, chosen vertex index plus weight of an edge between the chosen vertex and the current vertex. So that's the thing that we have to do. Now in one simple table that you can do it, the thing, see, I'm going to take in one particular table so you can get the idea. See, I have taken the figure also because it will be useful for me to take the vertices, everything. The formula which just now we have taken, same thing I have taken. L dash of t is equal to minimum of L of t uh, comma L of x plus omega of x comma t. Okay, so this is the index of the current vertex, index of the chosen vertex plus weight of the chosen vertex, weight of an edge of the chosen vertex and current vertex, that we have taken. Now carefully observe. See, index we have already calculated. No, index we have already calculated. See, here if I come, index of a b c d e f g, correct? Index of a b c d e f g that we have done. Now those things we are going to take it now here. See, same thing we have taken. Index a we have chosen already, so because of that index of that is 0. Now b, just now we have calculated, index of b is 4. See here, index of b is 4, correct? Now index of c now is 6 there, we have taken that. Index of d is 8. Then index of E is infinity, just we calculated, and index of F is infinity, and index of G is also infinity. Now that's the first thing that we have to write. Whatever the index we have calculated, once again if you want you can go through. So these are the index that we have calculated. Index of B is 4, index of C is 6, index of D is 8, index of E is infinity, index of F is infinity, index of J is infinity. That's what we have written here. Index, all the first row, if you have taken 0, 4, 6, 8, infinity and infinity, infinity, what we have taken. So this first row we got from the index. Now the point will comes here. Among this, the first row we have 4, 6, 8, infinity, infinity, infinity. Among that, can you identify the one with minimum index? That is this 4, correct or not? This one. Now we are going to choose this vertex. Now we are going to choose this vertex. Okay, that will be included in P. Already in P, A is there. Now since B is having the minimum index, we are going to choose that. Now this is the chosen vertex. B is the chosen vertex. Now with respect to this, we are going to calculate the index of remaining vertices. Remaining vertices means what? Index of C, D, E, F, G. Okay. Now first one by one we'll go with. Now I want to calculate index of C. Correct? So index of C we have taken 5 now. Earlier it was 6, but now it is 5. How we got 5? See, here I have explained. That formula we have studied there, that one. Minimum of, it is the index of the current vertex, previous index of the current vertex. See, previous index of the current vertex is 6. That's what I have taken 6 here, comma, index of the chosen vertex. So chosen vertex is B, correct? This one. This is the chosen vertex and index of that is 4. So that's what I've taken, 4 plus weight of an edge between the chosen vertex and the current vertex. That is weight of B comma C. Please see here in the figure, B comma C is 1. Correct? From this B comma C edge weight is 1. So that's what here we have taken 1. Weight of B comma C is 1. So index of current old index of the current vertex is 6. comma index of the chosen vertex plus weight of the edge of the chosen vertex and the current vertex, that is 1. So 6 comma 4 plus 1, that is 5. Among 6 and 5, 5 is the minimum one, so that I have written here in the same way. So now I want to calculate the index of D. How I am going to get that? First I am going to take minimum of index, previous index of the current vertex, that is previous index of D, comma index of the chosen vertex. Chosen vertex is B, correct? And the index of that is 4. That's what I have taken 4. And since there is no edge between B and D, so that I have taken weight of that is infinity. Minimum among this is 8. So that's what we have taken 8. In the same way, I can go with the index of E. So index of E is 11 that we have taken. How we got that? Minimum of, okay, previous index of the current vertex, that is infinity. See here itself you can make out previous index of current vertex is infinity, that I have taken here, correct, comma the index of the chosen vertex, that is B, and index of that is 4, plus weight of B comma E, edge B comma E is 7. That you can write down here. You can see from B to E weight is 7. Now that I have taken here 7. So among the infinity and 11, 11 is the minimum one, so that's what we have taken 11. In the same way, we calculated the index of F and G, correct? Now we have got the values 5, correct, then 8, then 11, infinity, infinity, correct? So we have got what? 5, 8, 11, infinity and infinity. So among these values, can you identify the one with minimum index, that is 5, correct or not? So we are going to choose now this vertex. So this is the minimum index with respect to the vertex C. So after A and B, we have to choose the vertex C now, because C is having the minimum index 5, correct? So in the next row, okay, so I'm going to leave this vertex because already it has been chosen. See, A has been chosen, B has been already chosen, now C has been chosen because of the minimum index. So I'm not going to conduct the index for that thing. Now we have to calculate the index for the remaining vertices D, E, F and G, correct? Index of those things that we have to calculate. Now I'll calculate the index of D. So that is 7. Now you may ask me again, so have you got that one? So again the formula. I think you people can tell me now the formula easily. It is the minimum of the previous index of the current vertex. Current vertex, now we are calculating D. Previous index of D is 8. Here itself you can find out. This is the previous index of D. That 8 we have taken here, comma the index of the chosen vertex. See, we have chosen C and the index of that is 5. So that we have taken here 5, plus weight of the edge between the chosen vertex and the current vertex. Chosen vertex is C and current vertex is D. So weight of an edge CD. So from the figure you can write down. So edge C is there here, edge CD is there here, weight of that is 2. So that's what we have taken 2 here. So 8 comma 5 plus 2. Minimum among this is 7. So that's what I have taken 7. Now I have to calculate the index of E. So how you are going to calculate minimum among the previous index of the current vertex, comma index of the chosen vertex, that is C, and weight plus weight of an edge between the chosen vertex and the current vertex, that is C comma E. So it was previous index of the current vertex is 11. From here itself you can make out. And chosen vertex is C and the index of that is 5. That you can write down. And the weight of an edge CE. So here you can come. This is C and this is E. Weight of that edge is 5. So that's what we have taken 5 here. So that's what among 11 and 10 the minimum is 10. So new index of E is 10. So like that I can calculate the index of F in the same way. So minimum of index of the previous index of the current vertex, comma index of the chosen vertex, and weight of an edge between the chosen vertex and the current vertex. So all these things you can get it from the figure and the previous thing. So you're going to get 9. Similarly, you can calculate the index of G, that we are going to get infinity. Okay, now we have with us the index of EFG, oh sorry, DEFG. So that is 7, 10, 9 and infinity. Correct? 7, 10, 9, infinity. Among 7, 10, 9, infinity, which one is the minimum one? 7. So that I am going to choose it now. That vertex has to be chosen. So this is the minimum index with respect to the vertex D. So I'm going to choose this vertex. After A, B, C and this one, I'm going to include D now. So my P contains now A, B, C, D. Okay, now I have to calculate the index of EFG now. See, that's what in next row I am not calculating index for A, index for B because already it has been chosen. C also has been chosen and D also has been chosen. This one. Okay, now we have to calculate the index for EFG. That's what we are doing it now. See, index of E. Here we have taken 10. The formula remains same. Minimum of previous index of the current vertex, comma, index of the chosen vertex and weight of a edge between the chosen vertex and the current vertex. Say previous index of E is 10 itself. We have taken that. See here. And chosen vertex is D and the index of that is 7 and there is no edge between D and E, so it will be infinity. So among this the minimum one is 10. That's what we have taken 10 here. Correct? Now we come for F. Same thing, minimum of previous index of the current vertex and index of the chosen vertex plus weight of an edge between the chosen vertex and the current vertex. So means DF. So this is 9, previous index is 9, here it is 9. So that's what I've taken 9 here, and 7 is the index of the chosen vertex and 5 is the weight of the edge between chosen vertex and this. If you want, you can say DF. Is there any edge from DF? It is. See here, DF and weight is 5. So that's what here we have taken 5. See here, 7 plus 5. So among this the minimum one is 9. Similarly, we can calculate infinity. So EFG we calculated, it is 9, 10, 9 and infinity. Okay, among this the one with minimum index is 9. So we have to choose this minimum index, correct? And this 9 is with respect to the vertex F. So with ABCD, which we have already chosen, okay, ABCD, I am going to include now F. Okay, so P contains A, B, C, D, F. Okay, so now we have to calculate the index of only two vertex now, E and G, because F just now we included. In the same way, using the same formula, we calculated the index of E as 10. Formula is same, okay, what we discussed earlier, and we calculated the index of G also, it is 17. Correct? And this one I have not taken because already this vertex has been chosen. Now among 10 and 17, the one with minimum index is 10. So here in this step I have to choose this 10. Correct? I have to choose this 10 and this 10 is the minimum index with respect to the vertex E. So along with A, B, C, D, E, F, I have D and F, I have to include now this vertex because this vertex E is of minimum index. Correct? Now my P will contain A, B, C, D, E, F. Correct? So in the next row, only one index I have to calculate because see, A is included, B is included, C included, D included, E included, F included. Correct? Only thing we have to calculate is index of G. So formula is same, minimum of the previous index of the current vertex, that is G, that is 17 here, that I have taken here, comma, the index of the chosen vertex. Chosen vertex is what? E. So what it will be? 10. So that I have taken here, correct? Plus weight of an edge between the vertices which has been chosen and the current vertex. Chosen vertex is E, current vertex is G. So is there any edge between E and G? Yes, it is. See, E and G, and weight is 6. That weight has been taken here, 6. Say 10 plus 6. So among the minimum 17 and 16, the 16 is the minimum one. So that's what I have taken. So this is the index of G at final stage I have got. So I am going to include G also for the P. So we included all the vertices now. First we included A, correct? Then B, then third one C, fourth one D, and then after D, we went with F. Then we came back to E. Then we came back to G. Correct? So we considered all the vertices now. This is what the vertices has to be chosen. So these selected boxes what we have taken, A 0 means index of A is 0, B index of 4, then C 5, D 7, and E 10, and F 9, and G 16. These shows that index and corresponding weights of the shortest path from vertex A to corresponding vertices. See, if you take that example, see here I'm going to take it. So you can easily make out now here from this graph you can make out. See, I have written A index is 0. Okay, so I've started with there. Now here, just now we have got index of B 4, correct? So means what? From A, we have to choose the path with minimum length 4. So this is the possible path that I have taken. Now index of C is 5. See, there are several paths from in the original graph A to C. There are several paths. In that one, you have to choose the one which gives the weight 5. Index is nothing but weight. So this is A to B, B to C that we have taken because 4 plus 1 it is 5. So this gives the shortest path from A to C. Now I have to go to shortest path from A to D. See, in the original graph, if you see, there are several paths. One direct edge is there from A to D with weight 8, but the index is telling it 7, means you are going to get one more path with weight 7. That will be the shortest path. Okay, now here that is from, see, like this, A to B, B to C, and C to D. So here we have done the same thing. Please check it out. A to B 4 plus 1 C, C to D 2, 4 plus 1 plus 2, it is 7. So A to B, B to C, C to D will be the shortest, minimal shortest path from A to C. Now from A to E you have to go with, see, E index is 10, means among all possible paths from A to C you have to choose the one with weight 10. See, that is A to B 4, B to C 1, that is total 5, and C to E 5. 5 plus 5 is 10. This is the shortest path from A to E. Now A to F I have to go with, and index of F is 9. So among all possible paths from A to F, you have to find the one with minimum weight 9. So that is A to B, B to C, C to F. So A to B is 4, B to C is 1, 5, and 5 plus 4 is 9. This will be the shortest path from A to F. In the same way, index of G is 16. Correct? How we are going to, among all the possible paths from A to G, identify the one with minimum weight 16. So that is A to B 4, B to C 1, 5, and C to E 5, 10, and plus 6. So 4 plus 1 plus 5 plus 6. Correct? So this gives 16. So this gives all possible paths, shortest paths from vertex A to remaining all vertices. See, indices will represent the weights of the shortest path. So in wordings, whatever the graph that we have got there, so in wordings we have written here A to B. Okay, A to B path length is 4, and C, between A and C it is A to B, B to C. Now between A and D the path will be like A to B, B to C, C to D, and between A and E the path will be like A to B, B to C, C to E. Between A and F the path will be like A to B, B to C, C to F, and path between, shortest path between A and G will be like A to B, B to C, C to E, E to G. That has been chosen, shown in the figure, and weights of this has been given here. Okay, corresponding weights, 4 plus 1 it is 5, 4 plus 1 plus 2 that is 7, 4 plus 1 plus 5 that is 10, 4 plus 1 plus 4 that is 9, and 4 plus 1 plus 5 plus 6 that is 16. So indices of the vertices has been calculated here. So this is what that we have to do in the Dijikstra's algorithm. we can take any graph and we can try to apply the concept to get the shortest path from particular vertex to all other vertices. Whether it is a directed graph or undirected graph, we can use the same concept. Okay, thank you very much.